Hi there, everybody. I'm Doc Harmon with another Tuesday afternoon science project. Today's topic is magic water, or water magic. We're going to have a lot of fun in a couple of minutes with some experiments. But first, let me tell you a couple of things about water, most of which you probably already know. You probably already know that 70% of the Earth's surface is actually water. So there's tons of water around, but most of it is seawater. Now, seawater is fine if you're a fish or an octopus or a lobster, but we need water without so much salt in it to live. So how much do we actually have? Let me just show you a little experiment here. Demonstration. Let's pretend that this is all the water in the world. Fresh, sea, everything. Now, how much of that is fit for us to drink? Because we know most of it is salt water from the oceans, but how much is available for us? Let me show you. See this little glass? That's it. All of this is seawater. Totally seawater. This is all the fresh water in the world. And this is what's available to all the billions of people who live there, along with their animals, and birds and insects. But even this is not quite all there is for us. Why is that? Well, a lot of it is tied up in glaciers, icebergs, snow caps, packed snow. Only a third of this is available to us. That's about it. This is frozen water. This is water for us. Watch. This is all the water in the world that's okay for us to drink. That's it. So it's a very precious commodity. It's a very precious resource. Treat it wisely, save it, and we will be fine. Now, lots of places in the world that don't have enough water. We don't want to be part of that. And this summer, maybe you'll have fun swimming in it, staying healthy, drinking it, using it to do experiments like we're going to show you right now. Before we do our dancing rice experiment, I want you to remember the science behind it. It's all about density, which in simple terms is how much things weigh compared to how much space they take up. Solids, like metal or wood, or even instant rice, are more dense than liquids, like oil or water, which in turn are much more dense than gases, like oxygen or carbon dioxide. So we have solids, liquids, gases. Keep thinking about it. Are you ready to do the dancing rice experiment? Here is what you're going to need. Remember, you can do this at home. You're going to need some instant rice. You're going to need some baking soda, not baking powder, baking soda. You're going to need some vinegar, and you're going to need a cup of water. Now, I put a little more than a cup in there just because a cup didn't look so good, but now we're ready to go. What you do first is to take, by the way, I just added a little drop of color to make it look good. Baking soda, we take a tablespoon. This is a measuring spoon, so I know I got the right amount. We put it in, and we stir it. Now you'll notice that it doesn't dissolve right away, but it does fairly quickly dissolve. Now once it's a little bit clearer, as a matter of fact, it's clear enough to go right now. Now we put in the instant rice. Again, a tablespoon. A heaping tablespoon. I also am going to stir that. Now you notice it's all floating. Now once I'm stirring it, you'll see that some settles to the bottom and some floats. Now, I think I'm going to add a little bit more to get more sinkers. There we go. Now, why does some float and why does some sink? Well, while they're absorbing this soda solution, let me show you this picture. This picture is of plain rice, which has not been cooked, and instant rice. You'll notice that the rice on the left has kind of a hard shell. That's called a hull. And the instant rice on the right actually has a lot of wrinkles and puffy things. Well, you may not know this, but the only difference between instant rice and regular rice is regular rice that's been cooked. And then they spread it out on baking sheets and dry it out, and that's what instant rice is. Now what I've got here is a fair amount on top. I'm going to spoon it out just because it's going to compete with the other rice. I'm going to leave mostly rice that's on the bottom. Now comes the fun part. Okay, so let's start this chemical reaction. I've got the vinegar, and I've got a tablespoon, and I'm not just going to dump it in because it might get too frothy. But here's the first tablespoon of vinegar. I'm going to push it down to the bottom to kind of stir things up. Now you can see it got kind of cloudy. We're going to put another tablespoon in and watch what happens. Now you'll see that things are stirring around a little bit, but you'll see a lot of the grains. I'm going to make it easier to see by shining this flashlight down there. Some of the grains are going up, and a couple of the grains are going down. We're going to accelerate that by adding more vinegar. Ooh, that's a lot of bubbles. Now what you're going to see is much more activity. We finally got enough vinegar in there to get the reaction going. Now they're kind of going to town, aren't they? This will go on for an hour, not quite at this rate. But this is something, remember, you can do it at home. It's a lot of fun. Okay, let's take a look at this optical illusion experiment we've been talking about. You can see I have a glass of water on the table, and I've taken a piece of cardstock and drawn 2 rows of arrows. Each row points in a different direction. Now what I'm going to do is to move the arrows behind the glass. Take a look at the bottom row of arrows, keep in mind the direction of the top rows, and watch what happens as it moves behind the glass. What's happening? The ones on the bottom switch around looking like the ones on top. That's the optical illusion. Is that cool or what? One last thing, everybody. If there's a science experiment that you'd like to see me do, send an email to info@discoverwcm.org and we'll try to do it for you. That's it for today. Bye-bye.